Yes, guys, I hope I'm audible and screen is visible, guys. Please let me know. Okay. Chaliye, a very good afternoon to one and all. A very good afternoon to one and all. And let us start again. Okay, so today I'll be starting with certain questions. I'll be starting with certain questions on yes, I'll be starting with certain questions on uninformed search algorithm, right? So yesterday we have completed the UCS and along with certain other algorithms. So today my aim is to complete, yeah, today my aim is to complete certain questions on uninformed search algorithms. And from tomorrow, I'll be starting with the informed search algorithm. Okay. So I mean, the list of questions that I have, I'll be doing it. Okay, and then from tomorrow we'll be starting with informed search algorithms. Chaliye. Okay, so yesterday we have done UCS algorithm, right? So guys, I just want you to do certain questions on UCS algorithm. Okay, so let us start. Yes, let us start with this question. Okay, so guys, today it would be more of a problem solving session rather than a theoretical session. Okay, chaliye, done. Okay, so solve this question. No, so we'll be doing one by one each and every question. So the graph I have made again. Okay, the graph I have made again. This is the graph. Now he says, let the search proceed using UCS starting from S to find a path to G. Okay, now he says, what is the path cost? Okay, of node D. At the exact moment the goal node G is chosen for expansion. So guys, again you should know UCS. If you know the UCS concept, I think very easily you'll be able to solve this. Okay, tell me, NAT type question, tell me. Yes, yes, you have done this. Okay, yesterday you have done this, but that question was bit different. This was the question. Okay, this was the question. Okay, but here what he says what is the path cost at node D. Okay, he says what is the path cost at node D. Okay, you don't have to find at G, right? Okay, so while applying UCS, how to apply UCS? How to apply UCS? Already we know, no? How UCS is applied, uniform cost search. So it is the algorithm that actually finds the shortest path, that guarantees the shortest path from a point to the other points. Okay, chaliye. Now let us start with point S. Okay, let us start with point S. After exploring S, I would be exploring A1 and B5. Okay, then the shortest path would always be explored at any level. Okay, so I would be exploring A1. So I have B5. Now B has how many children? B has a single child, that is D. Okay, so D, sorry, A has how many children? Yes, A has how many children? Sorry, again. So I'll start with S. Yeah, I'll start with S. S has two children, A along with the cost 1 and B along with the cost 5. Okay, so I would cut A. तो A has how many children? A has how many children? A has a single child, that is B. Okay. A has a single child, that is B. So up now B can be reached at a cost of 4, and here I am reaching this at a cost of 5. Okay. So B has two children, right? So B has two children, that is C and B. So I would update B5. I would update B5 by what? I would update B5 by B4 here. Okay, because I have a shorter path to reach B, no? तो मैं 5 की जगह क्या कर दूंगा? I would be updating this by B4. और A का एक और children, एक और child है ना? A का एक और child है, that is what? That is C. तो C कितना आ जाएगा? C11. Okay, that is C11. ठीक है, अब इसके बाद let us cut B4. Okay, let us cut B4. तो B has a single child. B has a single child, that is D. Okay, D7. D has a single child, that is 7. Okay, D has a single child, that is 7. Now I would be cutting. Now I would be cutting again D7. Okay, so C11. See, he says what? What is the path cost GD at node D at the exact moment? Okay, at the exact moment when the goal node G is chosen for expansion. Okay, when the goal node G is chosen for expansion. So bus very simple. I would be cutting C11. Okay, D7. So D has a single child, that is G. Okay, C has a single child. Sorry, yeah, D has a single child, that is G. Okay, so G, yes. Okay, तो 3 और 1 4 4 और तो 6. Sorry, B6 would be there. Okay, not D7. I would be getting B6. Sorry. I think I've done one mistake here. No, yes, I've done mistake. Yes, so I have B4 C11 है ना? I have B4 C11. I would be cutting B here. Yes, so I would be cutting B. B has a single child, that is D. Okay, so D would be how much? 3 plus 1 4, 4 plus 2 6. Okay, D6 and C11. Okay, D6 and C11. 3 plus 1 4, 4 plus 2 6. Correct. Okay, D6 and C11. Okay, I would be cutting D6. So yes, now I have C11. Okay, C11. Now D has how many children? D has a single child, that is G. Okay, D has a single child, that is G. Okay, D has a single child, that is G. Okay, so G would be reached at what? 3 plus 1 4, 4 plus 2 6, 6 plus 6 12. So G would be reached at a cost of 12. Okay, G would be reached at a cost of 12. Now I would be cutting C11. Okay, now I would be cutting C11. So the C11. So C has again two children, G and D. Okay, C has again two children. Yes, C has again two children, D and G. Okay, so I can reach D at what cost? 10 plus 1 11, 11 plus 2 13. Okay, but already I reached here at a cost of 6, so I won't be writing this. Okay, I've reached there at a cost of 6, so I won't be taking a longer path to reach D. So 10 plus 1 11, 11 plus 2 13. Okay, so I won't be reaching G. I would only be reaching there. I would only be reaching G. Okay, and that too at a shorter cost. That is 3 plus 1 4, 4 plus 2 6, 6 plus 6 12. So when G12 has been chosen, okay, when G12 is chosen for expansion, so at that moment, what is the cost at D? What is the cost at D? So that is 6. Okay, so when it has been chosen for expansion, at what cost I can reach D? So I can reach D at a cost of 6. So answer would be how much? Answer would be 6 here. Okay, answer would be how much? Answer would be 6 here. Okay, I hope you are getting this. I hope you are getting this. Okay, so correct. So correct answer would be 6. So these all questions can come, which actually tells you, no, which actually tells you to just I mean test, which will test the execution of UCS algorithm. Okay, तो guys ये question आपको मिल सकते हैं. Okay, तो I mean make sure कि आपने अच्छा practice किया हुआ है UCS लगाने का, so that these questions, no, you can answer all these questions. ठीक है. हाँ, ओके तो बस लास्ट लाइन इज ओनली दिस थिंग. व्हाट इज द लास्ट लाइन सिर्फ यही बोल रहा है कि व्हाट इज द पाथ कॉस्ट ऑफ डी ऑफ नोड डी एट द मोमेंट द गोल नोड जी इज चोजन फॉर एक्सपेंशन. तो जब आप जी को चूज कर रहे हो एक्सपेंशन के लिए, तब डी कितने पे एक्सपैंड हो चुका है, एट व्हाट कॉस्ट डी हैज बीन एक्सपैंडेड. वेरी सिंपल. तो डी इज एक्सपैंडेड एट अ कॉस्ट ऑफ 6. तो व्हाट इज द आंसर? आंसर इज 6 हियर. ओके, आई होप दिस इज क्लियर. ओके, चलो. Okay, question number 3. Question number 3 for you in UCS. Everyone, guys, everyone. Question number 3 for you in UCS algorithm.
Sir, your voice is not audible. Sir, your voice is not audible.
Yes, this is the, yeah, I think now I'm audible, no? Yes, I think yes, now I'm audible. Okay, correct, correct, correct. Yes. So this is the path that is found by the UCS. Okay. So very simple. How to solve this question? Very simple. Yeah. We'll be starting with node S. Okay. S has how many children? S has three children, A, B, and G. Okay. S has how many children? S has three children. Okay. A, B, and G. Now A can be reached at a cost of 1, G12 and B5. I would be cutting A1, then yes, B5, G12, and I can reach at C3. Okay. So I can reach to C3. Okay, A has a single child, that is C. So now I would be cutting C3, then C has a single child, that is G, and I can reach G at a cost of 7. Okay, done, done. Up now I will be cutting B5. So B has a single child, that is G. So I can reach G at a cost of 8. So I have three G's at a cost of 7, 8, and 12 respectively. So I would be choosing what? I would be choosing a lowest cost. Okay, that is G7. And what is the path? What is the path that I have been given? So this is the path. Okay, this is the path. Okay, so such questions may come where UCS algorithm, that should be clear to you. Okay, where you should be clear with the UCS algorithm. Okay, yes, you should be clear with the UCS algorithm. Right? Chaliye. Okay, now what is the answer for question number 4 if it is a MSQ question? Okay, tell me the answer for question number 4 if it is a MSQ question. ठीक है, अच्छा, take option C as correct. Since you do not know A star algorithm, take option C correct. Okay, I would assume option C as correct. Guys, yes, I want answer from you. I have given that yes, option C is already correct. Okay, tell me, it is a MSQ question. Try doing this, guys. Okay, so guys, here see option A, that is correct. Okay, UCS is guaranteed to find the optimal cost. Already we have discussed this. Okay, already we have discussed this. UCS is guaranteed to find the optimal cost. Already we have discussed this, right? Optimality, we have discussed this for UCS. Okay, optimality we have discussed, completeness that we have discussed, okay, and expansion order we have discussed, right? Acha, space complexity, this is order of B to the power D, time complexity, order of B to the power D. Okay, already we have discussed this. Now, on this only, this question has been framed that what is. Yes, UCS is guaranteed to find the optimal path. That is correct. Option A is correct. Then option B. Okay, option B. UCS is complete. Yes, that is also correct. Okay, what does complete means? It is guaranteed to find a solution if one exists. Okay, if all the step costs are greater or equal to a small positive constant. Okay, that is correct. Okay, now C is already correct. I told you C is already correct. Okay, now in a graph with some zero cost cycles, where, see, what is zero cost cycles? I mean, where the cost of any edge that is given as 0. Okay, that is a zero cost cycle. So a standard implementation of UCS might get stuck in an infinite loop. This is also correct. So to avoid this, we always use revisiting strategy. Okay, we always use marking strategy. Okay, we always use marking strategy. We won't be revisiting the nodes that has already been visited. Okay, we use the marking strategy. So guys, all the options are correct. Okay, all the options are correct. So here in this zero cost cycles, yes, a standard implementation of UCS might get stuck. Okay, so all the options are correct. So this, I think you can just write in the formula sheet for UCS. Okay, so guys, please take out your formula sheet, everyone. Okay, guys, please take out your formula sheet, everyone, and you can just write this in the formula sheet. Option D, you can just write as a note in the formula sheet. Okay, so it may get stuck in the infinite loop. That is why we use marking strategy, where the revisit. I won't be visiting again the notes that has already been visited by me. Okay, so guys, you can just write it. Okay, I'll wait for a minute. Please take out your formula sheet, everyone. Let us solve the next question. Okay, chaliye, now let us solve the next question. So yes, IDDFS. Okay, in IDDFS, just try to solve this question. For IDDFS, just try to solve this question. It is also a MSQ question. Guys, make a habit of solving MSQ questions. Okay, so try solving this question for IDDFS. Yes, guys, try to tell which is, what are the correct options? It is MSQ. More than one is correct. Okay, to make a habit of solving MSQ question. Okay, so how to solve this? Yes, how to solve this? See, IDDFS, Iterative Deepening Depth First Search. Okay, yesterday only we have done this. IDDFS, Iterative Deepening Depth First Search. So in IDDFS, in a graph with cycles, a standard DFS can get trapped in infinite loop. This is correct. That is correct. So IDDFS avoid this problem. Okay, how it avoid this problem? Because its underlying depth limited search terminates once the depth limit is reached. That is correct, because see, DFS gets trapped in infinite loop. No, to avoid this, what we do, we have used IDDFS, because it iterates. No, it iterates. So that problem is actually avoided. No, that problem is actually avoided by this. Okay, now, so what is second? If the graph contains edges with varying positive costs, if the graph contains edges with varying positive costs, IDDFS is not guaranteed to find least cost. That is correct, because UCS guarantees to find the least cost in the for the varying positive edge costs. Okay, so B is also correct. If the search space is infinite tree, okay, search space is an infinite tree but has a finite branching factor. Okay, so IDDFS is not guaranteed to terminate if no goal state exists. See, if no goal state exists, then IDDFS won't terminate. Okay, it won't terminate because it would start iterating it. ये बार बार क्या करेगा, ये iterate करता रहेगा. तो that is also correct. Okay, तो ऑप्शन सी इज करेक्ट गाइस. यहां पर ऑप्शन सी जो है वो सही है. ओके, तो अगर यहां पर मान लीजिए इफ एट ऑल इट इज अ इनफाइनाइट ट्री और फाइनाइट ब्रांचिंग फैक्टर है, बट अगर गोल स्टेट नहीं है तो आईडीडीएफएस करेगा ही नहीं टर्मिनेट. क्यों? क्योंकि ये बार बार क्या करता रहेगा, इट वुड बी टर्मिनेटिंग. तो दिस ऑप्शन इज करेक्ट. ओके, and if multiple goal state exist at the same shallowest depth d, so IDDFS will find one of them, but which one to find depends on the order in which operators are applied. सही बात है. if it is going from left to right, तो यहां से जो पहला गोल आएगा वो पड़ेगा. अगर राइट से लेफ्ट आ रहा है तो वहां से जो पहला गोल आएगा वो वाला पड़ेगा. तो आई होप यू आर गेटिंग दिस. तो ऑप्शन डी इज ऑल्सो करेक्ट हियर. ऑप्शन डी इज ऑल्सो करेक्ट. तो गाइस, what does IDDFS do? IDDFS says कि अगर देखो स्टैंडर्ड अगर लेफ्ट टू राइट जाएगा तो यहां से जो पहला पड़ेगा, आई मीन फ्रॉम हियर द फर्स्ट गोल दैट वुड बी एक्सप्लोड वुड बी द फर्स्ट गोल नोड. एंड इफ आई एम कमिंग फ्रॉम हियर टू हियर, तो जो यहां से जो पहला गोल नोड पड़ेगा दैट वुड बी द फर्स्ट गोल नोड. ओके, दैट वुड बी द फर्स्ट टू रीच. ओके, तो दैट मीन्स yes, this option is correct. Okay, this option is correct. So total ABCD, all the options are correct. Okay, all the options are correct. Okay, all the options are correct. Okay, so these are certain questions, no? So it would actually make a it will actually help you in I mean solving no MSQ questions. Okay, so guys, I would see today I'll only be discussing numericals. Okay, questions on uninformed search. So from tomorrow I'll be starting with the informed search. So I think it will be a very good session for you. Okay, chaliye. Okay, now let us start with question number 1. Okay, let us start with question number 1. Please solve this question. Okay, this is MCQ. This is MCQ question. Okay, try to give the correct answer. MCQ question. Okay. Yes, yes. In GATE MSQ questions, definitely, we can have all the four options correct. Okay. So MSQs are very risky. Okay. They are seriously very risky to solve. Okay. So we can have all the options in MSQ correct. Okay. Now in this question, question number one, consider a search problem with a uniform branching factor that is B greater than one, a start state N, S, and a shallowest goal state at a depth D. The path costs are uniform and positive. A DLS is performed with a depth limit L. Okay, with a depth limit L, which of the following statement is always true? DLS is complete if L is greater than D. Wrong. Okay, this is wrong. Okay, so which of the following statement is always true? DLS is guaranteed to find an optimal solution if L equals to D and path cost are uniform. This is correct. Okay, this is correct. See, if length is less than depth, so then DLS is not complete, no? But option B is correct here. Okay, option B is correct here. Okay, so DLS is guaranteed to find an optimal solution if length is equals to D and path cost are uniform. Okay, and path cost are uniform. Correct. Okay, so this is yeah. So option B is correct here. Okay, option B is the best one here. Okay, chaliye try solving question 2. Okay, try solving question 2. It is a MSQ question. Okay, guys, try solving question number 2. It is a MSQ question. Okay, so what is the answer? See, he says which of the following scenarios will depth limited search with a limit L explores the state space in the exact same sequence of node expansion as standard DFS do. Okay, so in what case DLS would search as DFS do? Okay, he asks in what case does DLS serve? Okay, in what case does DLS serve when DFS do? Guys, it is a MSQ question, but if you see option A is correct. Okay, when the state space in a finite tree and L is said to be strictly greater than the maximum depth of any tree. Okay, so when see, for example, this is a tree. Okay, for example, this is a tree, right? When I would be setting the depth, all depth greater than the maximum depth of any node in the tree. For example, the maximum depth of any node, for example, here d value is 2, no, depth of the tree is 2. So I would be setting the value of L greater than d. If I set this value of length that is greater than the depth of the tree, then obviously it is for sure that the depth limited search would behave as what? Would behave as DFS. So option A is correct here. I hope you are getting this. By if I said, मतलब अगर मैं इसकी डेप्थ को जो डीपेस्ट वाला जो इसका गोल नोड है उससे बड़ी हमेशा रख दूं, तो भाई डीएलएस डीएफएस ही तो बन गया। आप समझ रहे हैं ये चीज? बेसिकली मैं क्या चाह रहा था, मैं चाह रहा था जो डीएलएस में जो क्या है वो इनफाइनाइट लूप में ना फंसे, तो एक मैं लिमिट सेट कर दूं। अब ये कह रहा है कि आप लिमिट ऐसी सेट करो कि इसके डीपेस्ट नोड से ज्यादा ही हो, तो भाई डीएलएस और डीएफएस सेम ही तो हो गए। आई होप यू आर गेटिंग दिस। ओके, सो ऑप्शन ए इज करेक्ट। Okay, when the state space is a finite tree, when the state space is a finite tree and L is said to be strictly greater than the maximum depth of any node in the tree, तो that means yes, option A is correct. Okay, अच्छा, अब अगर मैं L को इक्वल टू रखता हूं डेप्थ ऑफ द शैलोएस्ट गोल स्टेट, सी अगर गोल स्टेट यहां पर है, फॉर एग्जांपल इफ हियर आई हैव द गोल स्टेट, मान लीजिए यहां पर गोल स्टेट है। ओके, और मैं जो जो मेरी जो लिमिट एल है इसको मैं गोल स्टेट के इक्वल रखता हूं, देन ऑल्सो दिस डीएलएस वुड बी इक्वल टू डीएफएस। आई होप यू आर गेटिंग दिस। पहले केस में भी सही बात थी। इन द फर्स्ट केस ऑल्सो आई हैड दिस थिंग, नो, व्हेन दिस लिमिट इज ऑलवेज ग्रेटर देन द डीपेस्ट नोड, देन ऑल्सो डीएलएस वुड बिहेव एज डीएफएस। इन द सेकंड केस ऑल्सो, when this limit L is equal to the depth of the shallowest goal state, तो if it is the goal state और इसके बराबर ही मैं लिमिट रख देता हूं, तो दैट मींस ये भी तो सही हो गया। ऑप्शन बी इज ऑल्सो करेक्ट। तो इसका मतलब ऑप्शन ए एंड ऑप्शन बी बोथ आर करेक्ट गाइस। ऑप्शन ए एंड ऑप्शन बी बोथ आर करेक्ट। आई होप आप समझ पा रहे हैं। आई होप यू आर गेटिंग दिस। ओके, आई होप यू आर गेटिंग दिस। तो देखो थोड़ा सा आपको समझना पड़ेगा यहाँ पे। ओके भाई, डीएलएस सेज व्हाट? डीएलएस अप्लाइज अ लिमिट। वो कहता है कि भाई डीएफएस की तरह पागलपंती मत करना कि नीचे जाता ही जा रहा है, यू डोंट डू दैट। तो ये बोलता है डीएलएस। अब डीएलएस ने तो स्टेट स्पेस अगर फाइनाइट ट्री है अच्छी बात है, और लिमिट जो है दैट इज स्ट्रिक्टली ग्रेटर देन द मैक्सिमम डेप्थ ऑफ एनी नोड ट्री। इसका मैक्सिमम 2 है और ये कहता है मैं 2 से हमेशा ज्यादा ही रखता हूं, तो डीएलएस इज सिमिलर टू डीएफएस, दैट इज करेक्ट। और दूसरी चीज क्या हो गई? व्हेन एल जो इसकी लिमिट है दैट इज इक्वल टू द डेप्थ ऑफ द शैलोएस्ट गोल स्टेट। भाई गोल स्टेट मान लो इसकी 2 पे है, तो शैलोएस्ट गोल स्टेट के बराबर भी अगर लिमिट रख गया, देन ऑल्सो डीएलएस एंड डीएफएस इज सेम। ओके, तो दैट मीन्स व्हाट? दैट मीन्स ऑप्शन ए एंड बी बोथ वुड बी करेक्ट। ओके, ऑप्शन ए एंड बी बोथ वुड बी करेक्ट। ओके,
Uh,
चलिए।
Sir, I have a question.
Now solve question number 3. Okay, try to solve
Sir,
question
am
number
I
3.
audible? Hello.
Okay, so you do one thing. Let us stick to option A and B. Tomorrow, I think we can discuss this again. Okay, so you for now you just stick to option A and B. Okay, in the previous question. Tomorrow we'll be discussing this again. Okay. Now let us focus on question number 3. No, tomorrow we'll be discussing this again. So here, if this is level 0, okay, this is level 1, this is level 2, and this is level 3. So he says with depth limit L equals to 3, this DLS is executed. Okay, with depth limit equals to 3, this DLS is executed, right? So this is executed till depth equals to 3. Okay, this is executed till depth limit equals to 3. Up now he says, let us see the option. No, the path that leads to the goal G being found is what? Is S to A to D, D to G. Okay, so I have to apply DFS till depth limit 3. Okay, I have to apply DFS. Okay, till depth limit 3. Up now he hasn't said anything, no, whether I am going from right to left, left to right. So always follow a standard implementation left to right. Okay, so first node A would be explored and then node B would be explored. Okay, so always follow a standard implementation. Okay, always follow a standard left to right implementation of the DFS algorithm. Okay, so I would be following this. No, I would be following this left to right. Okay, I would be following this. Okay, so now I would be making stacks, right? Now I would be making stacks. So after node S, firstly I shall explore A, then I shall explore B. Okay, so firstly I shall explore A, then I shall explore B. So in the stack, I would be entering in what order? In the stack, I would be entering in what order? So I want to explore A first, right? So in this order, I would be entering. Okay, in this order, I would be entering. So I would be exploring A first. Okay, then in the stack, okay, in the stack, A has how many children? In the stack, A has how many children? C and D. Okay, so I would be following a standard left to right implementation. So I want to explore C first. Okay, so after this, yeah, so I have already B and D already I have. Now C has how many children? C has how many children? C has a single child, that is G. Okay, C has a single child, that is G, right? So now I would be cutting or exploring G. Okay, and G is the goal node. So what is the path that is given? Path that is given is S to A to C, and C to G. Okay, this is the path that is given. Okay, this is the path that is given, right? So if you just see option A, SADG, and we are getting SACG. So this is wrong. Okay, the option A is incorrect. Okay, so always keep this thing in mind. We have to follow a single, I mean, either left to right or right to left. Okay, one implementation, one direction I have to follow. Okay, so he says SADG, that is wrong. No, because we would be having SACG as the path if I follow left to right implementation. Okay, up now next option is during the search, the fringe contains both node A and E simultaneously at some point. Okay, both contains A and E simultaneously at some point. So that is also not there. Okay, we don't have both the nodes A and E no simultaneously. Okay, acha, the total number of nodes expanded is exactly 5. Okay, total number of nodes expanded is exactly 5. How many number of nodes have been expanded? So if you just see, total of 4 nodes have been expanded. No, S to A to C to G. Okay, total number of nodes expanded, that is not 5. Okay, then node G is expanded during the search process. Yes, तो node G, तो अब यहां पर हाँ G को expand हमने नहीं किया. ओके, तो yes. ओके, तो यहां पर वी वोंट बी एक्सपैंडिंग, मतलब यस हमने नोड जी को एक्सपैंड नहीं किया, तो मतलब हियर ऑप्शन ऑप्शन डी वुड ओनली बी द करेक्ट वन. ओके, क्योंकि देखो यहां पे एस ए सी जी इज द पाथ दैट वी गॉट, है ना, एस ए सी जी इज द पाथ दैट वी गॉट, और इसमें ए और ई साइमल्टेनियसली नहीं है ना, और टोटल नंबर ऑफ नोड एक्सपेंडेड दैट इज 4. तो इसमें ऑप्शन डी ही जो होगा दैट इज ओनली करेक्ट. ठीक है, तो ऑप्शन जो डी होगा दैट वुड बी ओनली ऑप्शन दैट वुड बी करेक्ट. ठीक है, तो this was just I mean a question on DFS. Okay, depth first search, this was just a question on DFS. ठीक है, चलिए. Okay, now let us focus on bidirectional search. Okay, now let us focus on bidirectional search. Okay, now let us focus on bidirectional search. So yesterday we saw bidirectional search. Okay, yesterday we saw bidirectional search. So it is an efficient algorithm that is used to find the shortest path between a start node and a goal node in a graph or tree. Okay, देखो bidirectional search, it is a uninformed search that is used to find the shortest path between a start node and a goal node. Okay, in a graph or tree. Okay, तो अब यहां पर unlike traditional strategies like BFS and DFS, what happens is that bidirectional search no works by simultaneously exploring paths forward from start node and backward from the goal node, having the search space and greatly improving the efficiency for many problems. मतलब ये क्या करता है, what it do is it starts from the root node and it starts from the goal node simultaneously. ठीक है, ये साथ में ढूंढना स्टार्ट करता है पाथ को. ओके, साइमल्टेनियसली इट हैपेंस फ्रॉम स्टार्ट अलोंग विद द गोल नोड. ठीक है, अब यहां पे after this, okay, after this what happens, that a forward search and a backward search wherever they meet, okay, wherever they meet, so that combined okay, combined path would be given as the, okay, would be given as the complete path. Okay, so how it works, so we have a forward search starting from root node and we have a backward search starting from the goal node, and wherever they meet, okay, wherever they meet, they would be intersecting at a intersection node. Okay, they would be intersected, okay, at a intersection node, and that is what the complete path is found. Okay, there is the complete path after the intersection of both the nodes. ठीक है, तो दिस इज बेसिकली द मेन idea. Okay, or this is the core idea of bidirectional search. So what is the advantages in this bidirectional search? Okay, what is the advantage in this bidirectional search? So bidirectional search, the advantage is that, yeah, the advantage is that halving the search space gets halved. Okay, so the search space gets halved, so this is the major advantage. Okay, this is the advantage of using the bidirectional search. तो मतलब यहां पर जो search space होगा वो क्या हो जाएगा, दैट वुड बी हाफ्ड. ओके, एंड ग्रेटली इंप्रूविंग द एफिशिएंसी फॉर मेनी प्रॉब्लम्स. ओके, एंड ग्रेटली इंप्रूविंग द एफिशिएंसी फॉर मेनी प्रॉब्लम्स। तो गाइज यहां पर बायडायरेक्शनल सर्च इज यूज्ड ओनली, बायडायरेक्शनल सर्च इज यूज्ड ओनली व्हेन वी हैव अ वेरी लार्ज सर्च स्पेस। ओके, व्हेन वी हैव अ वेरी लार्ज सर्च स्पेस, तो देयर वो क्या करता है, वो ऐसा करेगा कि वो गोल नोड से भी ढूंढना शुरू कर देगा और रूट नोड से भी ढूंढना शुरू कर देगा। तो जहां पर भी मैच किया तो उस पूरे पाथ को कंबाइन कर देगा, इट वुड कंबाइन द पाथ वेयर एवर इट मैचेस, बस। और एक बार जब पाथ को कंबाइन कर दिया तो देयर he would be finding, there we would be finding what, we would be finding the complete path. Okay, so it initializes two frontiers, right? It initializes two frontiers. तो often queues या फिर sets भी बोलते हैं, but it initializes two frontiers. तो one for the forward search and one for the backward search. So it would expand nodes parallelly from both the frontier, and wherever we get a common intersection node, so it would stop the process. Okay, it would terminate the process. So this is how a bidirectional search algorithm works. Okay, and the biggest advantage is the space complexity, that is of the order of b to the power d by 2. Guys, please take out your formula sheet, and guys please write this. Okay, please take out your formula sheet, and guys please write it. That is of the order of b to the power d by 2, where b is the branching factor। ठीक है, b क्या हो गया, ब्रांचिंग फैक्टर, और d क्या हो जाएगा, सॉल्यूशन डेप्थ। तो इसी चीज के लिए बायडायरेक्शनल सर्च को हमने बनाया है, इसी चीज के लिए हमने बायडायरेक्शनल सर्च को बनाया है, जिससे कि जो स्पेस है, स्पेस कॉम्प्लेक्सिटी है, वो हाफ हो जाए। ओके, यस। अच्छा, और एक चीज आप और याद रखेंगे, यस, कि लेफ्ट टू राइट इंप्लीमेंटेशन वुड ऑलवेज बी डिफॉल्ट फॉर एवरी क्वेश्चन इफ इट इज नॉट मेंशन्ड। ठीक है, बट गेट कभी ऐसा करता नहीं है, वो हमेशा मेंशन करके देगा कि लेफ्ट टू राइट जा रहे हो कि राइट टू लेफ्ट जा रहे हो, वो हमेशा मेंशन करके देता है। ओके, तो स्पेस कॉम्प्लेक्सिटी दैट इज ऑफ द ऑर्डर ऑफ b टू द पावर d by 2। ओके, एंड ऑप्टिमैलिटी फाइंड्स द शॉर्टेस्ट पाथ बिटवीन बोथ द सर्चेस, यूजेस bfs। ओके, और यूसीएस। तो ये आप इसको लिख लेंगे कि इट फाइंड्स द शॉर्टेस्ट पाथ अगर बोथ फॉरवर्ड एंड बैकवर्ड सर्चेस यूजेस bfs और यूसीएस। तो bfs फॉर अनवेटेड ग्राफ एंड यूसीएस फॉर वेटेड ग्राफ। And completeness may guaranteed to find a solution if one exists. So guys, take out the formula sheet. Guys, please take out the formula sheet and write this. Okay, these are three important points. So first is space complexity is halved. Second is find the shortest path, and it uses bfs in unweighted graph, and it uses ucs for weighted graph. And completeness, it is complete, it is guaranteed to find a solution if one exists. Okay, if one exists. So guys, this you can write it. Okay, I'll wait for a minute, guys. Please, everyone, write this. Okay, so MSQ, MCQ question, definitely that would be mentioned in the exam, so you don't have to worry for that. Okay, and left to right and right to left implementation, that also would be mentioned in the exam, so you don't have to worry. But standard implementation is left to right. If at all that is not mentioned, start with left to right implementation. Okay, chaliye. Now, what are the real world applications? Real world applications is route planning in, I mean, GPS system finding the shortest route between the two locations. So there, GPS system uses bidirectional search. Often it uses bidirectional search. Okay, and automated puzzle solving, then network routing. This is also one of the very good application, no, determining the efficient path in communication or transportation networks. Okay, this is also one of the very good applications. Okay, acha, ab now what are the limitations? No, if you see the limitations, it is best suited for the problems where start and goal node both are known in advance. Okay, for example, if you don't have the knowledge regarding the goal node, no, if you don't have the knowledge regarding the goal node, their bidirectional search won't be suited. Okay, and it requires that it's feasible to search backward from the goal. Okay, and implementing backward search might be complex if actions are not easily reversible. Okay, so you can just give a read to the limitations, okay, of bidirectional search, right? You can just give a read to the limitations of bidirectional search. Okay, chaliye. Now now let us solve one question on bidirectional search. Okay guys, let us solve one question. Try solving this question on bidirectional search. Okay, this is MCQ. This is MCQ. So what is the correct option? Yes, everyone, try this question. Correct option. Oh, yes. So what is the answer? If you just see the answer here, see, the space complexity is reduced. Okay, the space complexity is reduced. Okay, but there is no point of, I mean, there is nothing given about the time complexity. Okay, so you can't actually I mean, judge regarding the time complexity, right? So space complexity is reduced, so this you have to remember. Okay, this you should remember, that space complexity is reduced to the order of b to the power d by 2. Okay, so there is no point, I mean, there is nothing given for time complexity, so option A is incorrect. Okay, option A is incorrect. Now if you just see option C, no, it significantly reduces the number of nodes generated to approximately 2 into b to the power d by 2. This is correct, no? If you just see, that during the forward search, half the number of nodes would be generated. During the backward search, half the number of nodes would be generated. So what are the total number of approximate nodes that are generated? So that is b to the power d by 2 plus b to the power d by 2. That is twice into b to the power of d by 2. Okay, so this is one of the options that would suit. Okay, this is one of the options that would suit here. Okay, by searching from both the start and the goal states, provided that predecessor of a state can be efficiently computed. Okay, so this is one of the options that would suit here, right? So there is nothing given about the time complexity, you don't have to worry for that. Okay, and option C is correct, because in the start node a total of half of the nodes would be explode, and during the backward search half of the nodes would be explode. So basically total twice into b to the power of d by 2 would be the approximate number of nodes that would be explode. Okay, that would be explode. Okay, so yeah, so option C would be the best suited option here. Okay, option C would be the best suited option here. Okay, chaliye, so I am giving you certain questions. I am giving you certain questions for homework. Okay, so this question I am giving you for homework, and again this question I am giving you for homework. Okay, this question I'm giving you for homework, right? So you have to do two questions in homework. Okay, for bidirectional search, right? Acha. Yes. Okay, chaliye. Now, guys, today I'll be stopping a bit early. Okay, today I'll be stopping my class bit early, and from tomorrow I'll be starting with the informed search algorithm. Okay, so today I'll be stopping here. Just do these two questions as homework for bidirectional search, right? And from tomorrow I'll be starting with, yes, and from tomorrow I'll be starting with the informed search algorithm. Okay, where we have to cover A star. Okay, and yeah, so tomorrow, yes, we'll be starting with this. Okay, chaliye. Okay, guys, thank you so much. And today I'll be stopping bit early. I'll upload all the notes. Okay.